Hello everyone. So we'll talk about stack today. Okay, this is our first video of our DSA playlist. You are a data engineer or not a data engineer doesn't matter. You have to have a basic to intermediate level of knowledge on DSA because writing, optimizing code is all that matters, right? And when we talk about DSA, we should start with stack, our first data structure that we are going to learn today. Imagine you have a jar and you are putting some coins into the jar every day, and at the end of the month, suddenly you realize that you are out of money, and so you need some money from that jar. The best way of get those coin is break the jar and get those coin out. But you don't want to break the jar, so the other way of doing this is picking every coin out of the jar and putting somewhere else. So the coin you put inside the jar at the first day of the month is going to be the last coin you retrieve from the jar at the end of the month, right? So the coin who goes first comes last. So first in, last out, or last in, first out. That means the coin you put at the end of the month or the last day of the month is going to be the first one to be retrieved, right? So that is LIFO or FIFO, both are same actually. This is what stack is. Now there are inbuilt operations like insert or push and pop element from stack. What is the top size? Now top pointer, what is top pointer? What is the function of top pointer in stack? I will obviously discuss about it when we are going to implement stack using Python, and don't worry about that. Full and is stack is full or stack is empty. Remember, stack is not a dynamic array. You define the size of the stack before even, I mean, during the initializations, and during every operations, if it is push or pop, you need to identify if the stack is full or if the stack is empty, right? So that is what actually a pain if you are working with a static data set, right? Now stack is also called ADT or abstract data type. That means you cannot access any element directly in the memory. You have to use the inbuilt method which are provided to you. Now there are some obvious question, when to use stack, when not to use stack. So if there is any design pattern question, design pattern not about like the design pattern. I mean I'm talking about valid parenthesis. Let's say they are given you a pattern and you have to find out whether that pattern is valid or not based on some rules. Think about stack. Think about if they have, if you are given an array and you have to find out whether the element, whether the next element is um, you know uh, be- greater than the previous one. Think about stack, of course. Okay. Now if you are given a problem where you have to access the elements in a reverse order, stack. Recursive problem, any recursive problem, they can be accessed, or tree based problem like a DFS, they can be accessed using stack, right? Whenever you meet with some any recursive or DSA related problem, DFS, depth first search, I'll come to that later when we talk about tree or recursion. Think about stack. But there are some patterns which are like anti-pattern of stack, when not to use one, right? If you have to retrieve or access an element the way they arrive in a list or in a collection, don't think about stack, okay? Because that's an anti-pattern. And if you need to retrieve the smallest or the largest element efficiently, remind the word, stack is obviously not the right choice, because stack you have to go with sequential access. Stack doesn't give you direct access, stack give you sequential access, okay? So these are like anti-patterns when not to use stack. So enough talk. Let's hit the board and implement stack using Python. I'm gonna use Spider, a very lightweight Python IDE. You can use whatever you have with yourself. Doesn't there is no restriction of choosing any IDE. So we're gonna create a class stack. Okay, I'm gonna inherit it with object. uh, See, the best way of writing any program in Python, use annotations. So from future import annotations, right? So def, we are going to create our constructor. And remember, I told earlier that we have to provide a size before we are initializing the stack. So self dot size equal to size, or self dot stack equal to, there is another element called top. Now top is like a pointer. Okay, top always tells you that where, if your stack is full or if your stack is empty, or where, what is the top element of your stack. Remember that jar full of coins problem. Okay, if there is a coin, the coin which is at the top of the pile is the top pointer. Think like that. Okay, now we have to implement, because stack is an ADT, so of course we have to implement some getter setter method to access the in-memory variables and its properties and in configs. Okay, so the first one is size. I'm going to call it get size. Remember, if you are trying to build an ADT which is a read-only type, then don't implement any setter method, because setter methods are very destructive, that can alter uh, your your variables or your object state at any time. Okay, that's a very destructive, and it can create memory leaks as well. So get size, I'm going to put this as, let's say, size, and is going to give me an integer value. Okay, so I'm going to return self dot size. Now some of you will ask, "Hey Kaushik, I can use, I can definitely directly access this thing. Can I not create an object of stack, like stack of 10 element, and then I can just print um, obj dot size, right? Let's do it. Let's do it. It's not. Because it's a private variable, right? It's a private element of stack class, so we cannot do that, right? So that's why we have the get size method. So just call the get size, and this is actually the basic idea of ADT, that you don't get to access a gets. Oh, okay, sorry, my mistake. This is actually the basic idea of ADT, that you don't get to access the elements of a class directly, right? This is a method variable top, instance variable, so you don't get to access the instance variable directly from the object, or from the object itself. Now let's get the top, right? Sometimes we need to know where the top pointer is pointing at, so that's why get top, and it's also will provide me an integer. So return. Okay, now we are going to implement push and pop method of stack. So let's start with push. So we need an element which we are going to push, and this method is going to return as nothing, so we will put as the return annotation is going to be none. But remember, I told earlier that stack is a static collection. We initialize the size of the stack when we are initializing the stack, so we cannot push any element into the stack if the stack is already full. So how to know if a stack is full, right? Remember, our stack top is, when our stack is empty, our top pointer is showing as -1. So let's say when we insert an element to a stack, is going to, I will put it as +1, right? +1 means stack pointer will increase by 1, right? Because there is one element inside the stack, and that's make the top pointer as 0. So if our size is 5, the size of the stack is 5, so 5 minus 1, that is going to be 4, because that is going to be 4 when our stack is full, right? So if self dot minus minus top is equal to self dot size minus 1, and we will raise an exception, famous exception, right? All of us have heard about it. I'm 100% sure about that. It's called stack overflow. Okay, Now, if that is not, that doesn't happen, we will, some people will write an else statement. But remember, if your if statement is there and there is no elif, then please don't write else, right? Just write whatever you want here, because eventually if your if statement or that particular code block doesn't execute, it will eventually execute the line number 26 and then so on, right? So that's it, it actually considered as a bad coding practice. Okay. Okay, so that doesn't happen. Then what we are going to do, we are going to increment our top pointer by 1 plus equal to 1. Okay, and we are going to push an element inside the stack, self dot top, and that's going to be element, right? Similarly, we need to find something, we need to pop something from stack, and that will give us what should be our annotation, and that should be object, because we don't know what we, because it's not a homogeneous stack. We are not implementing any homogeneous stack. We are implementing a heterogeneous stack. We can store a number or a string or a boolean, whatever we want inside the inside stack, so it doesn't matter. So that's why the annotation return should be object. Okay. So what should be our pop now? Again, we have to check if your stack is empty. So stack dot top equal to -1. Then we will raise an exception, and it will be similar, like stack is empty. Stack is empty. Okay, fantastic. Or else, what we are going to do? We are going to get the element. Element is self dot stack self dot top, right? And self dot, we have to initialize this particular memory block with none, correct? Because that is what our initialization was. We are initializing it with none, right? So we'll initialize it with none, and then we will decrease our top pointer, top minus equal to 1, and then we will return element. Okay, so this is how our pop met this is how the pop will work. Now it's time to test our code, right? We will create an object, let's call it obj equal to stack, and we will create a 4 element size. First things first, obj dot let's say get size. We will print it. Okay, let's say after that we are going to push obj dot push, and we are going to push an element into the stack. Let's say we will push 10. Okay, and let's say we will push 20, 30, 40. Okay, now let's run it. Okay, that's fine. This is console, by the way, and in this console we can find out obj here as well. Yes, now let's say obj dot get size, this 4, right? Now obj dot get top, that's staying at 3. Now let's try to push an element into the stack. Okay, let's 100. We are pushing 100 into the stack. Yes, it raised an exception the way we expect. Now let's start popping and pop elements from stack. You see, pop always happen from the top end, not from the bottom end, from the top end, and that's why it's LIFO. For 40, the 30, then 20, and then 10. You remember, like, we inserted 40 at the last, so the first thing, so the first element to be popped out, that is 40, right? Now let's try to pop stack is empty. So I hope guys you enjoyed this session, and what is stack, how we implement stack. I am sure like in 80% cases in interview nobody is going to ask you to implement stack in Python or whatever the language you are comfortable. But still, understanding that how stack behaves is, I think it's a good stepping stone to our journey of DSA. So we'll see you in our next video, and probably I'm going to talk about queue, linked list, many things in DSA, many interesting things. So stay tuned. Thank you.